Now we're going to discuss the challenge problem at the end of your packet. You have an organic alcohol that has only C, H, and O in it, and it's burned to produce 44 grams of carbon dioxide and 27 grams of water, and you want to get the empirical formula. So to get the formula, remember, you're going to need to know moles. You need to know moles. But when you do a lab, you're really only measuring grams, so eventually we're going to have to convert. So I like to call these blob problems. What I mean is that the reactant that you have is only composed of, in this case, C, H, and O, but you don't know what it is. You're going to burn it, so of course you need oxygen. It's O2 because it's diatomic. It makes carbon dioxide and it makes water. You know that it made 44 grams of carbon dioxide and you know it made 27 grams of water. And you know that the whole thing weighed 23 grams. So what we need to do is look for a link. The link is going to help you from the reactant to the product because all of the carbon here had to become all the carbon here. And you have another link that all of the hydrogen here had to become all of the hydrogen here. So you have two links in this problem from the reactants to the products. So if we find all the carbon in carbon dioxide, that means we know all the carbon in the blob. And if we know all the hydrogen in the water, then we're going to know all the hydrogen in the blob. And of course, if we know the carbon and the hydrogen and we know the total, we can subtract to get the oxygen. So how do we know how much carbon is in 44 grams of carbon? It's by percents. Remember that percents are the part over the whole for grams. Percents are grams. So carbon weighs 12, and carbon dioxide weighs 44 altogether. So 12 out of 44 is going to be carbon, which you can easily do in your head. It comes out to be 12 grams of carbon. Okay, by the same token, hydrogen weighs 2, because there are 2 of them in water. All of water weighs 18. So 2 out of 18 is 1/9. Let's not forget about our fractions. 1/9 of 27 is 3. So there are 3 grams of H altogether in the blob and 12 grams of carbon altogether in the blob. So let's write that down. 12 grams of carbon. We have 3 grams of hydrogen. And of course, since these two weigh 12 and 3, which is 15, the oxygen must be the leftovers, which is going to be 8. Okay, because all these have to add up to 23. So now, because we have grams, that's not going to help us for our formula because we need moles. So we're going to convert each of these. Carbon weighs 12 grams per mole, so that's going to equal 1 mole. Hydrogen weighs 1 gram per mole, so this is going to weigh, or have 3 moles. Notice I'm just using H, not H2, because H2 is when it's by itself. It's in a compound here, so we're not using diatomic hydrogen. Same thing with oxygen, we're using 16 because it's in a compound, it's not by itself O2. And 8 over 16 is 0.5 moles. I bet you didn't think you could do this without a calculator, but you can. So now we need to get a simple ratio and divide by the smallest, which is 0.5, divide by 0.5, divide by 0.5. So that's going to be a 1, that's going to be a 6, and that's going to be a 2. So that means that the whole formula is going to be C2H6O. That is the empirical formula, the simplest formula for this hydrocarbon, and that's what we were trying to find, the empirical formula. So, to recap very quickly, you take your blob, you look for links, you find a piece of each thing that is the link. Once you get each one, you could subtract if you had to get the missing piece of the blob. You take all your grams, convert them to moles, divide by the smallest, and get a simple ratio. This will help you with your homework tonight on number 79. And even though they're using milligrams in 79, you could just pretend they're all grams and they'll be the same answer. See you tomorrow.